Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 9 learners, and welcome back. Welcome back to our Term 3 live lessons. My name is Sianda Madlala, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's term and topic, we'll be looking at the knowledge area, it's energy and change, right? We'll be looking at energy and change, and as well as our topic for today will be forces, right? Topic for today is forces, and specifically we'll be looking at the types of forces and contact forces, to be more exact, right? So let's quickly look at our lesson objectives. Right. These are the following things that we should achieve by the end of this lesson. So when this lesson ends, we should be able to explain that a force is a push or a pull that is exerted on an object, right? We should be in a position where we are able to explain that a force is a push or a pull exerted on an object. Secondly, we need to be able to identify the Newton as the unit measure of force, right? We need to be able to identify Newton as the unit measure for force. Also, we need to be able to describe the effects of forces, right? So when you push or pull on an object, we need to be able to describe the effects that take place there. Also, we need to be able to list the main types of forces as contact and non-contact forces, right? Then later on, we need to be able to describe contact forces. And all this information is found under the CAPS document on page 71. Right, now let's move on and look at our pre-knowledge, right? Which are some of the things that we have done in the previous grades, and probably same grade, and it lays the foundation to today's topic. In grade 5, we talked of energy and movement, right? Then later on in our grade 7, we talked about the force of gravity, which is the force that pulls everything down towards the center of the earth. Then also in grade 8, we talked of static electricity, right? We talked of static electricity. So these are the topics that lay a foundation to today's topic. Right. Now let's look at our baseline activity, right? We need to write down this baseline activity so that we can test our knowledge in terms of how far we understand so far, right? So number one says define force, right? Then number 2 says copy the table below and decide whether the force in column B is pushing or pulling for the given motions in column A, right? So the motions in column A, we have roller blades moving forward, stretching an elastic band, and as well as a hairdresser drying your hair with the blow dryer, right? So now it is 2 questions, but for number 2, you still need to have to draw what? The table, right? So I'm going to give you 5 minutes to complete this activity. Then after that, we shall meet and mark together. Welcome back, grade 9s. Now we are going to look at the solutions together, right? Number 1 was saying define force, right? So how can we define force? Force is an action of pulling or pushing on an object, right? It is an action of pushing or pulling that is exerted on an object, right? Don't forget to mark your work. Then number 2, copy the table below and decide whether the force in column B is pushing or pulling for the given motions in column A. Column A, roller blades moving forward, right? Is that pushing or a pulling force, right? That is what? A pushing force, right? Because as you are rolling the roller blades, what are you doing? You are pushing your feet forward, right? So it is a pushing force. Then stretching an elastic band, right? Stretching an elastic band. What are we doing? We are pulling, right? So it is a pulling force. Then hairdresser drying your hair with the blow dryer, right? What is that doing? It is pushing air out, right? So it is a pushing force. Are we together? Right. So now I'm going to give you a quick minute to copy down the corrections. Then after that, we shall continue together. Welcome back, grade 9s. Now, don't forget, we still have our WhatsApp number in which you can send in your answers, ask any questions, or give us any comments regarding this lesson, right? So the WhatsApp number is 079-578-2908, right? Don't forget, 079-578-2908. Right. So now let's continue with our lesson, starting off with the important terms that are in this lesson. The first one there is force, right? We need to know what a force is before we talk about these forces, right? So a force is an action that can be described as a push or a pull on an object, right? When you are pushing or pulling an object, we are applying force. Then we have contact force. Contact force is now the force that is exerted when two objects touch each other, right? When the objects are in contact with one another, we say that one is a contact force. Then we have non-contact force. And non-contact force now is the force that is exerted over a distance without the objects touching each other, right? So the non-contact forces are also called field forces, right? So field forces is a synonym for non-contact forces. Then we have gravitational force. Gravitational force now is a pulling force that bodies exert on each other over a distance due to their masses. We also have Newton, which is the unit of measurement for force, right? It has the symbol N, right? So Newton is the unit of measurement for force. We also have magnetic force. And magnetic force is the force that two magnetic materials exert on each other over a distance. Then lastly, we have electrostatic force. And electrostatic force is the field force that arises through differences in the electric charge of objects. So now let's just quickly take a quick break so that we can fix some of the discrepancies that we are experiencing now. Welcome back again, grade 9s. Now we have sorted out the issue, right? And apologies for that. Right. So now these are the important terms that we are going to come across as our lesson proceeds, right? So now, starting off now, what is a force, right? Because today we're talking about forces, types of forces, and specifically contact forces, right? So what is a force particular, right? Think of your terminology, think of what we have covered now, right? So we said that a force is a push or a pull that is exerted on an object, right? So that push or a pull on an object can either cause the object to move, to stop, or even change direction, right? So now think of it. When you are pushing an object, what does it do now? It starts to move, right? When you are pulling an object, it moves, right? Or it can stop moving, right? And as well as can change direction from where it is coming from, right? So here is an example of a force, right? We have two basketball players here. They are throwing the ball at each other, or vice versa, right? So what is happening here? They are applying force, right? As this one is pushing the ball, this one is receiving the ball and stopping the ball from moving. And he pushes the ball back to the other player, where the other one catches it, stopping it from moving and changing direction again as he pushes it back to his partner. Are we together, right? So this is one example of force, right? We're trying to instill the the definition of force, right? It is an action of pushing or pulling on an object, right? So in physical sciences, we say that a force is anything that can make an object to accelerate, right? It can make an object to build up speed. Are we together? So now note one thing. If any object is stationary, not moving at all, right? It will not move unless a force is applied on it, right? It will not move, and it will not move. It won't start moving without what? A force. So a force is needed, whether it's a push or a pull, to make that object move. Are we together? Right. So let's explore some of these examples of forces, right? Like when you are squeezing water out of your cloth, right? What are we doing here, right? You are pulling and pushing at the same time, right? To twist the cloth and to be able to squeeze the water out of it, right? Here is another example, right? You are playing with your toys there. As you are pushing the car, you are applying force, and the car will not move unless you apply a certain force, whether you are pushing or you are pulling the car, right? Same as a wheelbarrow. It will not move unless it is pushed, right? Or pulled, or unless a force is applied on it, right? Here is another example, right? You can see these two sheep, they are pulling each other on that trolley, right? They are pulling each other, and at the same time, the other one stops pulling, and now the trolley stops moving as well. Right. So forces act in pairs, right? They act in pairs, meaning for every action that you apply, there's going to be a reaction. right? So that's like our example that we have here, right? When you are pushing against the wall, you are applying what? A pushing force and some action, right? You are doing the action of pushing against the wall, and also there's a reaction from the wall trying to resist what? Your push, right? So now, here is another example here, right? You have two elephants playing on a seesaw, right? For every action that is applied here, there is a reaction, right? So elephant number one is applying somewhat, some action, right? Some action pushing down what? On the seesaw. As this elephant pushes down on the seesaw, what happened? What happens? The reaction comes from elephant number two as the seesaw goes up, right? Right? So here we notice what? The elephant or elephant number two starts to go up, right? And that is the reaction from the action that is applied by elephant one, right? So forces come in pairs and they act in pairs. For your action of pushing, there's going to be a reaction of what? Of the object moving or not moving. Are we together? Right? Resisting what? The move. So there's going to be a reaction after an action, showing that forces act in pairs. So now, hence we see that we're going to talk now about effects of forces. As I've said, think of it, right? When you are pushing or pulling on an object, there is obviously going to be an effect, right? So what are the different effects of forces now, right? So a force can either change the shape of an object, right? It can change the shape of an object. Not only that, it can increase the speed of a moving object, which is what we call acceleration, right? It can cause any object to build up speed. Also, it can decrease the speed of a moving object, right? And which is what we call deceleration, right? It cannot decrease the speed of a moving object. Also, when pushing or pulling or when applying force, it can change the direction of a moving object. Not only that, it can also cause a stationary object to move, right? We can move a stationary object from one place to another, right? And as well as it can stop completely, can completely stop a moving object, right? So let's look at some of the examples here. Right, we said that force can change the shape of an object, right? So look at this person here, right? He is using his muscles to flex on this can, right? So he's applying force as he is pushing inwards, right? As he is applying his force, what happens to the can now? It starts to become squashed, right? Changing its original shape, right? This is because of the force applied to it. Also now, right, you can see that we have two friends playing with this car here, right? The other one is pushing and the other one is inside the car, right? So the more this one pushes, what happens? The more this car builds up speed, right? It causes what? Acceleration, right? It can cause a moving object to build up speed. Look at this one now, right? The ball is coming from this direction to him, right? As this ball is coming towards him, he hits it back with what? With a bat. What is happening now? The ball goes back to where it's coming from, right? As it goes back to where it's coming from, it's changing direction, right? It's because of the force that is applying on the bat and the ball as he hits the ball with the bat, right? Also, as we mentioned that it can completely stop a moving object, right? So this one is driving his car, right, at high speed and suddenly hits a brick wall. As he hits this brick wall, what happens to his car now? It completely comes to a stop, right? This is because of the force that is applied by this brick wall onto his car. right, onto his car. Then the car comes to a complete stop. Are we together? Right? So these are some of the effects of forces that we notice, right? As we push or we pull on objects, these are the kinds of effects that we may experience. Are we together? Right. So as we said that forces, they act in pairs, right? So what happens here when they act in pairs? We need to find out the overall force acting on an object after all forces are combined, right? And that one we call it a net force, right? A resultant force. For the car to be able to be stopped by the brick wall, it means that what? The brick wall applied more force than the car. Are we together? The brick wall applied more force than the car. For that guy using a bat to hit that ball and change the ball's direction, it means that guy used what? More force than the ball has. Right? So which is what we call what? The net force, the resultant force. Right. So sometimes we have forces acting in the same direction, right? They are all going in the same direction. So for such forces, in order for us to determine the net force or the resultant force, we need to add them together, right? So for example here, right, we have 10 newtons of force going to the right-hand side plus what? Another 10 newtons of force going to the right-hand side as well, right? So we said that we add them together. So it's going to be 10 plus 10 newtons. It equals to what? 20 newtons of 10 to 20 newtons of force, right? Or 20 newtons net force going to the right-hand side. That is our resultant force. And sometimes now we have forces acting in opposite directions, right? They're working against each other, right? So we need to find out the overall force that is acting on that object after all these forces are combined, right? So we need to find our net force here. So the forces acting in opposite directions, that's when now we subtract them in order for us to determine the net force. So for example, again, we have 10 newtons of force going to the right-hand side against 7 newtons of force going to the left-hand side. So these ones, they are in opposite directions, right? They are working against each other. So hence we do what? We minus them. So these 10 newtons minus 7 newtons, it gives us what? 3 newtons of force to the right-hand side, because the right-hand side is applying more force than the one going to the left-hand side, right? It applies 10 newtons of force, whereas the other one going to the left-hand side is applying 7 newtons of force. So our answer here is going to be 3 newtons of force going to the right-hand side. That is our resultant force, right? So now, let's look at more examples now. So we have these two teenagers here trying to push the piano around. Probably they're doing some spring cleaning, right? But they're trying to move the piano around the house. So what is happening here? There is one thing that they are doing. They are moving it in the same direction, right? They are working together towards the same direction. The other one is pushing the piano, the other one is pulling the piano, right? But they are all going to the same direction. So the girl here is applying 25 newtons of force, of pushing force to the piano, whereas the boy is applying what? 20 newtons of pulling force on the piano, going in the same direction as the girl is pushing to, right? So what did we say about this? We said that when forces are applied in the same direction, they are added together to determine the size of this net force, right? So what are we going to do here? It is 25 newtons plus 20 newtons to give us 45 newtons to the right-hand side, right? That is the amount of force applied on this piano, right? So here we have another example part of forces acting in opposite directions. Now it's a different story, right? We have two dogs fighting over this rope, right? We have Danger and Snoopy fighting over this rope, right? But now Danger is applying what? 10 newtons of force, of pulling force against Snoopy, right? Snoopy is applying what? 12 newtons of force against Danger, right? And mind you, they are going in opposite directions. So who is going to win the rope over to themselves? Right? So what do we do here? Let me remind you. We said that when two forces act in opposite directions, you subtract the smaller force from the larger force in order to determine the net force. Are we together? Right. So what is going to be the result here? The net force will be in the same direction as the larger force, right? So let's look at this information. So Danger is applying 10 newtons of force, whereas Snoop is applying 12 newtons of force. So what do? We minus, right? So it's going to be 12 newtons of force minus 10 newtons of force to give us what? In the larger what? Force, right? To give us 2 newtons of force to the right hand side. So meaning what? Snoopy is going to win the rope over to himself. Right. So we can notice that now sometimes forces can be balanced and unbalanced, right? So what do we mean when we say forces are balanced, right? When they are balanced, it means that they are the same in size but acting in opposite directions, right? So a balanced force does not cause any change in motion, right? There will be no movement, right? And there will be what? No resultant force, because they are equal in size but acting in opposite directions, right? They are equal in size but acting in opposite directions. Hence, we say that they are balanced and the net force is going to be 0 because there will be no change in motion because of what? The equality in size. So looking at these examples here, right? We have two friends also playing tug of war, right? So their forces are the same and they're acting in opposite directions, right? As the forces are the same, one is pulling to the other side, one is pulling to the other side as well. But there's not going to be any movement because the forces applied are the same in size, right? So here is another example here, arm wrestling, right? Person 1 and person 2, they both have, or they are both the same in size, right? They both have the same strength. They are both applying the same amount of force. So hence there is no movement here, right? There is no movement and the net force is 0 because their forces are balanced. But now, when forces are unbalanced, right, it means the size is not the same on either side, right? So meaning what? An unbalanced force will always cause a change in motion, right? There's going to be some movement, and obviously the net force is going to be greater than 0, right? So when unbalanced forces act in opposite directions, we can find the net force, right? So here is another example here, right? Tug of war again, right? We have this guy here playing tug of war against two women, right? So the women are applying more force than this guy, right? So hence they are able to pull him towards their side, right? Because of what? Their force is greater than the one he is applying. So also the same goes for arm wrestling here, right? Person 1 and person 2, right? So what happens here? Person 2 is applying more force than person 1. Hence, there is a change in motion. Hence, the net force is greater than 0, right? Hence, person 2 is able to win this challenge against what? Person 1. Right. So now we are getting to the types of forces that we're going to discuss for today, right? So there are two main types of forces that we know, right? Or two main types of forces under this topic, right? So these two types of forces are contact and non-contact forces, right? So I'll start off with contact forces. Contact forces now, they act when the objects are in contact with one another, when the objects are touching one another. That's only when the force can act, right? But non-contact forces, right, they can act over a distance without the objects touching each other. Looking at non-contact forces, right, like magnetic force, we are able to pull magnetic materials using a magnet from a distance, right? Electrostatic force and gravitational force, right? But today's topic is dwelling more on contact forces, and we're going to discuss these contact forces in detail, right? But before that, let's engage in activity one, right? So number one is saying what is a force, whereas number two is saying what is another name for non-contact forces. Number three says what are the two main types of forces. Number four says what is the difference between a contact force and a non-contact force. So I'm going to give you a quick 4 minutes to complete this activity, and don't forget to send in your answers as soon as you are done on 079 578 2908, right? So let's meet again after you've completed the activity. Welcome back again, grade 9s. Don't forget to send in your answers on 079 Right, now let's look at the solutions. Number one, what is a force? Right? So we define a force as an action that can be described as a push or a pull on an object. Right? Number two, another name for non-contact forces. Those are field forces. Right? So what are the two main types of forces? Those are contact forces and non-contact forces. Then number four, what is the difference between a contact force and a non-contact force, right? So a contact force now, the objects need to touch each other for the force to act, right? But now, when it comes to non-contact forces, right, they can act over a distance without the objects touching each other, right? So that's all for activity one. So quickly take a 1 minute to copy down the corrections quickly. Then after that, we shall meet again for more of the lesson. Welcome back again, grade 9s. Right, now let's carry on with our lesson. Right, contact forces, right? So contact force is a type of force, right? It's where now the objects need to touch each other and be in contact with one another for the force to act, right? So now, as I've said that a contact force now leads to the forces need to touch each other for the force to act, right? Sorry, the objects need to touch each other for the force to act. And that includes frictional force, tension force, and compression force, right? Those are the different types of contact forces that we know. Are we together? So now, for example, right? In order for you to be a bodybuilder or lift some weights, right? You need to touch what? The weights, right? You need to touch the weights and lift them up, whether you are pushing or pulling. But the fact of the matter is that you need to touch them, right? There needs to be contact between you and the weights in order for you to lift them up, right? So you are pumping some water out of the borehole, right? That tap there, you need to be able to touch it, hold it, and start pushing downwards, right? So that you are able to pump the water out of the borehole, right? Frictional force. The wheels of your skateboard need to be in contact with the surface in order for you to be able to skate on the surface, or also do what? To stop the skateboard, right? So the fact of the matter is that contact needs to be there in order for the force to act, right? That's all about contact forces. The objects need to touch each other so that the force can act, right? So tension force. Tension force is a type of a contact force, right? Contact needs to be there in order for tension force to take place. But what is this tension force, right? So tension force now is a pulling force on a body, causing it to be tightly pulled, right? It is a pulling force on a body, causing it to become taut, right? So it is usually facilitated by what? A rope, a cable, or wire, right? When it is pulled tight by forces acting from opposite directions, right? So let me emphasize. Tension forces are exerted through a string, a rope, cable, or wire, right? When it is taut or tightly pulled by forces acting in opposite directions. That's when we have tension force. So tension force usually it is used to carry heavy loads, right? It is used to carry heavy loads. So now, another example here of tension force, right? When you are playing tug of war, right? This is where we form what? Our tension. Are we together? This is where we form our tension, where the rope is tightly pulled or where it has become taut, right? So as I've said that usually tension force is used to carry heavy loads, right? As we can see here, we have what? A cable trying to pick up the container using this crane, right? Using this crane, and this is where our cable becomes tightly pulled, creating what? Tension, right? So also here, this is an example of tension force where a rope is used to pull objects up and down, right? Up and down, causing what? Some tension, right? So also when we look at our national grid, what? We notice that those cables are connected to these pillars, and there's some tension between the pillars on the cables, right? Where they are tightly pulled, creating what? Tension. Right. So here we have another example of contact forces, which is compression forces. And compression forces now, these ones are a pushing force, right? It is a pushing force on a body that causes it to become squashed, right? It's one of those forces that change the shape of an object, right? It's one of those forces that change the shape of an object when the force is applied, right? It is a pushing force, and it occurs when a force presses inward on an object, right? So when you are pressing inward or pushing inwards on an object, right, it can cause the object to become compacted, to become squashed, to change its shape. Are we together? So what happens now when you're pushing inwards, right? It changes shape, right? It changes shape because of what? The relative positions of atoms and molecules of the object change as well, right? When we are applying what? Compression force. So here we have another example of compression force, right? This spring, right? So there's some compression right here, right? Compression because of what? It changes shape, right? It becomes compacted and it becomes squashed because of what? Of the pushing inward, right? Because of the pushing inward. Also, these are examples of compression force, right? Looking at this structure here, right? It is pushed inward and now it has changed shape, right? As it bulges on the sides, right? Because of the compression force applied to it. Same as image number 2, right? And image number 3, right? On that toy there, right? As the person is compressing the toy, we can see its eyes popping out and changing shape, right? This is because of the compression force applied to it. Now moving on to frictional force as an example of contact forces as well. So force of friction, right? Force of friction happens when two objects touch and slide against each other, right? So they create friction in between them, right? They create what we know as friction. So they need to touch and slide against each other, right? So looking at this example here, right? Probably this is your home and you're doing some spring cleaning and you're trying to move the sofa around, right? It is too heavy for you to carry, but you can only slide it on the carpet. So what happens as you slide it on the carpet then? There's some force of friction between the couch and the carpet, right? Because they are sliding against each other, right? So the force of friction always acts parallel to the surface and it also acts in the opposite direction to the movement of the object, Hence, we say that they are sliding against each other. One is going in the other direction, whereas the other one is going in the opposite direction, right? So as well as when you are driving your car, right? You drive your car at high speed. At some point, you hit on the brakes to try and stop the car. There is some friction taking place between the wheels of your car and the tarred road, right? And it makes sure that your car is able to stop immediately, right? Or stop eventually. Right, so let's look at another example of this frictional force, right? So frictional force obviously can prevent objects from falling. Not only falling, it can also prevent objects from moving, right? So if you push against a heavy box that is standing on the grass, right? The grass exerts a frictional force on the box against your pushing, right? Hence the pushing becomes harder and harder, and you get tired as you push, right? This is because of the frictional force between the grass and the box, right? So looking at this example here, right? This person is pushing this box downwards, right? As he is pushing now, he hits an obstacle here. The obstacle now creates more frictional force, making it harder for him to push the box further, right? Because of what? More friction added between the surface and the box. Are we together? So if your pushing force is smaller than the frictional force, meaning that the box will not move at all. So now, let's quickly look at activity 2 and test our knowledge so far, right? Activity 2 says, identify which contact force is exerted in the actions stated below. Number 1, the force exerted in the string of beads worn around Anya's neck. Number 2, Kavi presses onto the plastic tomato sauce bottle to squeeze out the last bit of tomato sauce onto his fried chips. Then number 3, Tapelo uses soccer boots when playing a soccer match to prevent him from slipping and falling on the field, right? So simply tell us which type of contact force is on the statements listed below, right? So I'm going to give you 4 minutes quickly to complete this activity. Then after that, we shall mark together. Welcome back again, grade 9s. Now, a big shout out to Saint Barnabas, right? So, they've been interactive with us on WhatsApp, and I hope I was able to help some of you with the lesson, right? So, now let's quickly look at the solutions, right? Number one says the force exerted in the string of beads worn around Anya's neck, right? The type of contact force is tension force, right? Why am I saying it's tension force? It is tension force because of what? The string is holding a load of beads. Are we together? Then number two, Kavi presses on the plastic tomato sauce bottle to squeeze out the last bit of tomato sauce onto his fried chips, right? That is compression force, right? Because as he presses onto the plastic tomato sauce bottle, he is compressing the bottle, squashing the bottle, or make it to become compacted, right? So he's applying compression force. Then number three, Tapelo uses soccer boots when playing a soccer match to prevent him from slipping and falling on the field, right? That is frictional force, right? Because the soccer boots have a lot of what? Grip, and now they do what? They create more friction between the surface and them, right? So that is frictional force, right? So let's take a quick minute to copy down the corrections. Then after that, we shall wrap up our lesson. Welcome back again, grade 9s. Now, I hope you had enough time to copy down your corrections, right? So, we are simply going to wrap up our lesson, right? Since we no longer have more WhatsApp questions, so we're going to summarize what we have learned for today. After that, we're going to give you a chance to copy down the homework, right? So, now, today we're talking about forces. And we said that a force is an action that can be described as a push or a pull on an object, right? When you are pushing or pulling on an object, you are applying force, right? So we said that this force now is measured in units of measurement called newtons, right? Newtons with the symbol N, right? Also, we talked about that forces that two objects exert on each other, they always act in pairs, right? For every action applied, there's going to be a reaction. And also, we talked about that there are effects when applying force, right? A force can change the shape, direction, and the speed of an object, right? Also, it can cause an object to stop moving. It can move a stationary object, right? It can change its shape, direction, and speed as well, as we have mentioned. So also we said that there are two broad groups of forces, right? We have contact forces and non-contact forces. Whereas contact forces, the bodies need to touch each other for the force to act. Non-contact forces, the force can act over a distance without the objects touching each other, right? And on contact forces, to mention a few examples, right? We talked of tension force, right? Which is a pulling force, right? We said that it is facilitated by ropes, cables, or wires, right? Where they are used to carry heavy loads. Frictional force, right? a force where two objects are sliding against each other, right? And also compression force where we push inwards and it can cause the object to change shape or become squashed, right? So we also have a homework here. I'm going to give you a quick minute. Then after that, I'm going to say my goodbyes, right? Take a minute quickly to copy down the homework. Then after that, it's bye-bye. Right, grade nines, I hope you have enjoyed today's lesson, right? So let's meet again on the next lesson where we'll be talking about non-contact forces. So you know what to do. Go home, open your textbook, give yourself some time to study on this topic so that when we come back and meet here, it's an easy going process, right? It's an easy teaching and learning process, right? So from me to you now, thank you and goodbye.